Good day and welcome to the Math Salon. My name is Dr. Nimende. For those of you who are new to the Math Salon, please, you're welcome. Feel free. The Math Salon has a series of videos spanning different topics of mathematics, and its intention is to help you improve on your mathematical skills. This way you get better prepared for your class exams as well as national examinations. And for me, I would wish that these skills are the ones that you need beyond school, that you will need for life's problems, to be able to analyze problems critically and search for suitable solutions for them. So the mathematics is also useful beyond school. Today we'll be looking at solutions to the quiz that we did on the 20th of January 2022 for the advanced level. So here at the site, of course, I already gave you the answers, and then I'll try to solve some of the questions that have not been done before in other quizzes so that we don't spend much more time. You can always go back and look at those solutions for previous quizzes to get the answers that were required for this new quiz. Before you look at these solutions, please, it's important that you try the quiz yourself. Go back, look at the quiz questions, try them, get your answers down, then you watch the solution. This way you'll be able to estimate how much you've learned in this process. I would also not repeat all the questions, so it's important that you actually take the quiz. I will put just the important data on the board and then solve. Sometimes for time purpose, I would try to pre-populate my board so that I don't have to write all the time till the end, but I'll make sure I explain everything to you. Okay, let's go. So for this, the first question was given there. Maybe we'll just do the second one. Yeah, because the first one was already done in previous quizzes. Okay, I just thought if at the end I think it's really necessary, maybe we will do the question number one. But then let's handle number two. For question number two, you are given two functions, p of x as minus x cubed plus bx squared minus ax plus 3. And another one, q of x, like this. The idea was to use your factor theorem idea. You have done that in school. I will try to remind you. In the factor theorem there, the idea that, if you know that a function has a factor, it means that when you divide that function by that factor, there is no remainder. Similarly, for the remainder theorem, it means if you divide a certain function by a certain factor, you get a remainder. If the remainder is 0, okay, it means that that particular function that you divided with can be considered a factor. That's not the most important. Let's just see what was required. So this, you were told that this function has a factor 3 minus x. That means when this is divided by 3 minus x, the remainder is 0. And you were also told that it has a remainder 45 when divided by x plus 2. If that is the case, then you are given a second one as well, with also extra property. This one has remainder 0 and minus 6 when divided by x plus 2 and x minus 1. I just used another name for the same thing, so you get used to different terms that are used. So a remainder 0 actually means that this is a factor as well. This is not a factor, it leaves a remainder, so it's not a factor. After having solved that, for the purpose of this quiz, the idea is to make sure that you don't just copy the answer from any pamphlet or any textbook or something, but that you actually try to solve. That is why the answer that I need from you has to be a plus b plus c plus d. So you have to do something, not just guess the answer. So if that is true, then p of x, I will just write it in a nice form. Mathematics is beautiful. The minus sitting in front makes it not that nice. It's like, hair that has to be plated. When plated, it looks much beautiful. So I will change the positions. So in that case, my minus x cubed goes to the end, and I write it in ascending order of x, but that doesn't matter. So 3 minus ax plus bx squared minus x cubed. Since we are told 3 minus x is a factor, it means that the x value that I have to substitute in the function should come from this small equation here. I take minus x this way, and I get that 3 is equal to x. So I should put x equal to 3 in this function. And the answer should be 0 because it is a factor here. So if I substitute 3 in all the place of x there, then I come out with this. So here 3 remains. 3 times a is minus 3a. 3 squared is 9 times b is 9b. 3 cubed is 27, and this minus is there. I can just fix this, and if you arrange it well, you come out with this equation. That a is equal to 2b minus 8 as equation number 1. You have the second information, that if now I divide it by x plus 2, if I do that, then x is equal to minus 2. Means I can put minus 2 into the function. And then the answer should be 45, not 0, because this one was not a factor. So p of minus 2, so I still write here, this is 3. Minus 2 times minus there becomes 2a. Minus 2 squared is 9, 9b. Sorry, minus 2 squared is 4. 4 times b is 4b here. And minus 2 cubed is minus 8. And this minus becomes plus 8. That's that. If I rearrange that as well, I get here 2a and that. So 3 plus 8 here is 11. And if you come here and push it out, you get 34. But then there is 2, there is 4. So I can divide all through by 2. If I do that, then I get a, 2b, and instead of 34, I get 17 as the second equation. I can solve these two equations by substitution. I can take 3b minus 8 and put here. Then I get 3b minus 8 plus 2b is equal to 17. If I solve that, I will get a is equal to 7 and b is equal to 5. I take the second one. So I already have two components of what I need. I already have here and I have b here. So this is 7 here. This is 5 here. If I take this other one, I write it, this is cx cubed minus 3x squared plus dx plus 6 here. So we are told I have to remainder 0 and minus 6. In a similar way, just like the other, x plus 2 equal to 0 means x equal to minus 2. So I will substitute x equal to minus 2 in the place of x. So q of x becomes q of minus 2. And I put minus 2 here. So minus 2 cubed is minus 8. That's why I have minus 8c here. Take minus 2, I put here. Minus 2 squared is 4. 4 times minus 3 is minus 12. Minus 2 times d is minus 2d. And then plus the 6. This is equals to 0. That's the remainder. If I solve that, I come up with this equation here as equation number 3. D is equal to minus 3 minus 4c. You also told when divided by this, the remainder is minus 6. That means similar way. So you get x minus 1 equal to 0 means x is equal to 1. So I can do q of 1. So this is 1 cube is 1 times that is c. 1 square is 1 times minus that is minus 3. 1 times that is just d and the 6. If I arrange that way, I get c plus d is equal to minus 9. This is 6, it comes here minus 12 plus 3, that's minus 9. If I solve those two equations, 3 and 4, then I will see c is equal to 2 and d is equal to minus 11. So I can just say 2 minus 11. And if you do that well, you get 3. And the answer was C here. That was equation number 2. Okay, I think, yeah, let's look back at the equation number 1. Equation number 1 gave us an equation like this. X squared plus 2k plus 2 multiplied by x is equal to minus 2k minus 5. And that this equation had roots alpha and beta, and that the roots are equal. We also told that k is positive, it's greater than 0. The idea was that you first look for k, and you substitute k here, and then find the sum of roots plus the product of roots of another equation which has roots 2 alpha plus alpha beta, 2 beta plus alpha beta. So the first thing we have to do is look for k. The fact that you had two roots that were equal meant that what I will call a d for discriminant, because the discriminant is used to discriminate your roots, to tell you the type of roots you have. Are they real and equal, real and different, or there are no real roots, which means they are complex. So in this case here, so I'll write my formula that as d is equal to b squared minus 4ac. There are many other videos that have shown exactly how you come up with this discriminant. Please feel free to watch them to better understand. So if that's the case, then I rewrote my equation in a nice form. This was built for an equation that is of the form ax squared plus bx plus c. So it's important that equal to 0. You also arrange your equation in that form. So I carried all this to the other side. That's why I got now 2k plus 5 equal to 0. So this is my a position here. It's a, which is equal to 1. And this here is my b. And this here is my c. So if that is true, I have b squared, this b here, squared minus 4 times a is 1, that's the 1, times c is here 2k plus 5, that's it. And this should be equal to 0 because the roots are equal. If you expand this, this is 4k squared plus 2 times 2 is 4k times 2 is 8k plus 4k minus 4 times 2, that is minus 8k. 4 times that is minus 20. And if you arrange well, then you would see you have something like 4k squared plus 8k plus 4 minus 8k minus 20. And if you arrange that, you come out with 4k squared minus 16 is equal to 0, because this k falls off and the 4 from minus 20 is minus 16. You can solve for k there and you see there are two possible values of k, plus or minus k. But you were told that k is positive, so it cannot be minus 2, so k is 2. If k is 2, I can substitute it in this equation and I get this new equation here, where k is 2, 2 times 2 is 4, plus 2 is 6. K is 2, 2 times 2 is 4, plus 5 is 9. This new equation, of course, with the value of k known now, has roots alpha and beta. So if I look for the sum of this roots of this equation, then it's alpha plus beta. The formula is minus b on a. I also show that in so many videos. Please feel free to look at them. There are more than 50 of them. If you really want to better understand mathematics and improve your skills, look for time to watch them. So if this is the case, then it's simply minus b on a. So this is minus b here is 6 divided by a. So that's minus 6. And the product of root is c on a, which is 9 divided by 1 equal to 9. You are not told that there is another equation that we don't know, but the only thing you know is that the roots are 2 alpha plus alpha beta, 2 beta plus alpha beta. Because he has information about alpha beta, it means that it depends on the roots of this other equation that we already know. So we can take this indirect path to get that information without necessarily knowing the equation. So to look for this now, I made it a bit that you give me the sum of root and product of root, just because it's the quiz, that's an open book. So you think a little beyond just looking from one past question or one answer and the other, but that you give some time to reflect and think a little. If that is the case there, then means my sum of roots here, I will just add these two roots up. So my sum of roots is just adding them up. This is 2 alpha plus beta plus 2 beta plus alpha beta. So if I take these two terms together, I can factorize 2 and I will get alpha plus beta. If I take this together, there are 2 of them, 2 alpha beta. You can just copy these answers and fit them. Alpha plus beta, I know here is minus 6, I put it there. Alpha times beta, I know is 9, I put it there. So 2 times minus 6 is minus 12. 2 times 9 is 18. If you sum this, you get 6. We can do that too for the product of roots. For the product of root, I try to make it simpler for myself. Since I know that alpha beta is already 9, I can just replace them with 9 here instead of rewriting. So this is 2 alpha plus 9, 2 beta plus 9. If I open this, this is 2 alpha times 2 beta, it becomes 4 alpha beta. 2 alpha times 9 is 18 alpha. 9 times 2 beta is 18 beta. 9 times 9 is 81. Alpha beta is 9 here. So I can fit it in the place of that. So 4 times 9 is 36. I can take my 81 just close to that one. And I solve it. There's 18 here, there's 18. So I can factorize the 18. And I will get in bracket alpha plus beta, which is minus 6. I can replace the minus 6. And if you solve this, you get 9. Then of course you have to look for the sum of roots and the product of roots. So that is then our 6 plus our 9. 6 plus 9, and that is 15. So that one was C then. For question number 3, answer was D. You were given this differential equation like this, and you were told that x should be greater than 1, just to say that x cannot be minus 1 here, otherwise this is not defined, say. But all the same, this is what we're given now, there's the information. You are now asked to solve for this differential equation. And then in the process of solving that equation, you have to introduce a constant. And that constant can be solved if you have this information here, that y is equal to 0.5 when x is equal to 1. So in order to do this, it's important that we learn how to separate the variables. So all the y's go to one side and all the x to the other side. So to do that, I will divide both sides here by y plus 1. Here y plus 1. If I do that, this goes off and I get that. I can similarly divide both sides by x plus 2. And then x plus 2. So that in this case, I have now 1 divided by y plus 1 dy is equal to, I take the x that way, x here on x plus 1, x plus 2. So you get this. Once you have this, we can now integrate on both sides. This integral is a simple one. You just check that the derivative of the denominator is equal to the numerator. Derivative of d with respect to y is 1, and that is 1. So then the integral is simply the natural log of y plus 1. and this is equal to here. Here, you have to first play with this. You have to actually look for this as a partial fraction. But luckily, we have nice factors here, so we can just do, the simple fast technique they call cover up. So I have to express this in the form a over x plus 1 plus b all over x plus 2. So I need to look for this a and this b. The a is what is here and the b is what is there. So to look for that a, I simply cover this one here. And look for what value of x makes this 0, that is minus 1. If I cover this here and I put minus 1 here, I have minus 1 divided by minus 1 plus 2, that is 1. So minus 1 divided by 1 is minus 1. So that's the coefficient there. To get the coefficient of x squared, I cover the x squared. I check which value of this makes it 0. X is minus 2. So I cover that here. So I get minus 2 here. Minus 2 plus 1 is minus 1. Minus 2 divided by minus 1 is plus 2. And we get that. So these are the partial fractions of this particular rational function there. So if I do this, it becomes simple to integrate. So my first integral here just works. I remove minus here. I see that the derivative of the denominator is the numerator if the minus is by the side here. So it's just the natural log of x plus 1. I put 2 outside as well. And I see that it's also a natural log of x plus 2. Because this is an indefinite integral, there's a constant that we don't know. So it's customary to introduce the constant with an ln as well. We could just say c here. But if it's ln k, then that's a better way of looking at it. So there is this constant. But to get this constant, I need the extra information that was given to me. We're told that y is equal to 1, y will be half. So I can put that information here, y is half. So this becomes 1 over 2 plus 1. I'm looking at this, right? So this is ln here, y plus 1. So this is half plus 1. X is 1. I put x1 here. That becomes 1 plus 1 is 2. X is 1. 1 plus 2 is 3. And then this one we don't know. So we are just left to simplify this. The log of a ratio is the difference of logs. So I have log of a on b. Then this is log a minus log b. So I would apply that there. So this is simple ln 3 minus ln 2. If I take minus 2 this way, it becomes plus ln 2. So they cancel with that. If I take this way, I get minus 2 of ln 3 plus ln 2. So I just get only one of the minus 1 of the ln 3. And that's what we get here. But I'm looking for k, not ln k. We also know that if you have n log a, then it's the same like log of a to the power n. So I can take the minus 1 on top. It comes here to become minus there. So this is 3 to the minus 1. I can drop my logs here. Just like saying you drop logs or you take the anti-log. So then this is 3 minus 1 is equal to k. 3 to the minus 1 is 1/3. And that's why the answer was D there. For question number 4, 5, and 6, these have been done at least 3 times in different quizzes. So please go back and check previous quizzes to see their solutions. The answer was D, A, and B. Sometimes I just replace the numbers to make it a little different, but the method remains exactly the same. Or sometimes I swap the positions of the answers so that you don't cram what you had in the previous quiz. So for question number 7, you were given this information that 3 sine 2 mu was equal to 1, and that mu is an acute angle lies between 0 and 90 degrees. They were asked to find this. So based on the information we have, 3 sine 2 mu is equal to 1. That means I can divide both sides by 3. So sine 2 mu is equal to 1/3. My idea is I have to go close to a way that I can split. I can have sine mu and cos mu. This way they are still combined. So if I do that, I can use some of your double angle formula that you should also know from trigonometry. The sine of 2 mu is 2 sine mu cos mu. Actually, sine of 2 mu is sine of mu plus mu, and that is sine mu cos mu plus cos mu sine mu, and that's just 2 of them, 2 sine mu cos mu. This you've seen that before, and also we've done that in previous quizzes. If that is the case, then it means my sine 2 mu is written as 2 sine mu cos mu, and that is 1/3. So if now I now have split it into 2, but that's not sufficient. This is what I have to look for. But I know that there's a relationship I can establish between this and that. If I square this, I will get sine mu squared 2 times this, and the minus is there. So that is a minus here, excuse me. So here then you have minus 2 sine mu plus cos square mu. So if you do that, I can take this in front and get sine this plus that, excuse me, there, minus here. So there's that plus that, that's okay. From the standard identity, this is equal to 1 minus 2 sine mu cos mu. 2 sine mu cos mu is 1/3. Then I get 1 minus 1/3 is 2/3. And then sine mu minus cos mu is equal to square root of 2 on 3. And that's equal to, yeah, because this was squared, right? I need the square root of both sides. So to get this alone without the square there. But then this is root 2 over root 3. It's not typical. It's not too nice to leave a root under. It's not a problem, but it's not the best of things. For us, that doesn't look beautiful. So I can multiply up and down by root 3, and root 3 times root 3 is 3, and I get root 2 times root 3. And this can be combined to become root 6. That's root of 2 times 3 on 3. And if you check none of the answers that way, okay, so that's why E was there, that neither A, B, or C. Also, I saw that question number 8, 9, and 10 were also done in the previous quizzes. So we will not do that here. I will just advise you to go back and look at them, please. And if you have a problem with a particular question for this quiz, just leave me a comment and I will come and respond to you. If need be, make a video to explain. Okay, thank you for participating, and I'm really impressed with those who took the courage to take the quiz. I wish you success in your exams. Bye.